example of herb B in cancer. So I have cancer. You don't have to justify why we should study cancer. Yeah. But I'm going to go from cancer to herb B. That I might want to justify. So what is known about herb B in cancer? Now, if my study is trying to look for genes that I can delete, then I might want to justify why I'm doing a deletion study. And how do I decide which of the herb genes, or why a deletion study versus other kinds of study? Maybe I want to have a couple of sentences justifying that. And then I come right into my study. So we're going to look for which herb genes we can delete to stop cancer. What you want to do is, by the time you repeat your research question here, and repeat your nucleus, that all of those key ideas, the reader believes them and feels that they're important. So basically, it's your universe of 5 is in here, and by the time they see it at the end, they have to understand, yeah, we need to look at that universe of 5. That makes sense. And these aspects of the universe of 5 are new. This is what an introduction is supposed to do. How about the discussion? Just very briefly, a discussion roughly goes in the opposite direction. So if introduction is a funnel from general to specific, the discussion should be a funnel in the reverse direction. And there is not one way to write a discussion. Here's one way of several. But I would say, I really recommend whatever structure you use, always respect the signpost sections here, the beginning, and here at the end. So at the beginning, we're going to summarize why we did this in the first place, what our key results are. And then I'm going to go through the major results. In the discussion, you do not have to mention every result. No one expects that. And in some cases, it may be helpful. Bundle some of your results. You don't maybe even have to mention some of them. It depends on what your nucleus is. Whatever I decide are the major results, I'll try to go one by one. And what I suggest you do is, for example, in this first result, briefly summarize the result. Don't give a lot of numbers. Reviewers and editors don't like a lot of numbers data in the discussion. You can have some, but you already have the results section. They don't want it again. They want the discussion to be a story, where I can go, even if I can't make sense of the graphs. So briefly summarize to remind the reader what you saw in your study, and then compare it with other ones. And then very important, which you may often forget, not just younger scientists, come to some conclusion. Don't just write, we measured 20, and a previous study measured 10. Moving onward to the next result, we measured 5, they measured 6.5. For our third result, because what is that? That doesn't help. So if you do your work, and it's similar to other studies, make some useful conclusion of that. Does that mean then that that's the truth? Does it mean that you've extended the literature to more complex organisms? What does it mean? If you measure 10 and they measure 30, what does that mean? Does that mean there might be differences based on the gene, based on the ecosystem, whatever? Give us some review. Editors, more than anyone, editors love when your discussion gives food for thought, when it suggests future research questions. The more that you can show how your experiments trigger interesting next research questions, the more luck you will have. What editors don't want is a closed story that says, it so happens that nobody's measured the flow of this river at this temperature. We measured it and it's 12. Thank you very much. Because the editor may say, well, you're right, no one has measured that value because no one cares. Right? So it would be more helpful to say, no one's measured this value, and if we knew that value, we could do something better. Here we go, we measured it, and it's 12. Then you might even try to help them put the 12 in perspective. Is the 12 surprising? Is it what you expected for that kind of river? Something, for you. That's what editors really like. So make sure you come to a conclusion. And so on, for each major result. And then, I encourage you toward the end of your study, acknowledge your limitations. Now, this is a tender area, a sensitive area. You know the game. You did the experiments. You know that there's that control that would be really nice, but you didn't have time because you had to go on holiday with your family, or those particular controls didn't work out, or the animals died early or something. So you have this debate, how much of all of the defects in your study should you really put in paper? Yeah? And people ask me, should I mention that? my advice to you is, especially better journals, the reviewers will see everything. Right? If they have any experience in your field, they know the games that you play, they know the compromises that people make. My advice is not to hide most of your problems here, but to actually acknowledge them and turn them into positives, in the sense you turn them into proposals or recommendations for future work. So again, we're back to what I said the editors like. They want to publish research that other people will build on. Now, why do editors want to publish research that other people will build on? Yeah, you're good. Impact factor. Because if this paper is done well enough and kind of closing the available research space and saying, well, don't bother looking here so much, we should look more here. And then another paper comes along and looks there, it's probably going to cite that first paper. And that means more impact factor for the journal, which means more money for the journal, and happiness for everyone. That's not fun. You don't want to be happy, right? All right. Or at least to graduate. Okay, first graduate, then happy. All right. And then sort of at the end, kind of connected to this, so that you can even combine that into a single paragraph. Some journals even want a separate section. But anyway, you can combine it into, okay, future work should do exactly what we failed to do.